Hi everyone, I'm Netra and I'm your secretary for this year. Today I'm going to teach you about what an Arduino is and get you started on some simple circuits so you can build your own cool projects by yourself even without physically having an Arduino. So an Arduino is like a circuit or a board with a microcontroller inside that you can send instructions to with some code or programs on your computer. There's a lot of cool projects and technology you can make with Arduino. So the board looks like this. And the first and most important thing to know is the layout of the board because there's some simple rules that you must know before you make the most complex projects. I'll go through the circuitry in detail later, but in general, know that a circuit consists of a positive end and a negative end. On the Arduino, we have multiple pins, and we have specific pins called the power supply pins. And depending on the board and its voltage, the voltage varies. But on this board, or the Uno, you get to select if you want to supply either 3.3 volts or 5 volts to the circuit. And this voltage is considered the positive side. And there's also a ground pin, which supplies 0 volts, and it's considered to be the negative pin. Also, there's various other pins, but for now, let's focus on analog and digital pins. And you put your wires into these, and if you use these pins for output, they'll supply certain voltage values depending on the board. So this board is a 5 volt board, so they would supply 5 volts to circuit. So you don't have to you don't have to put it into the 5 volt pin. So yeah, let's look at the board close up. And you can see like the USB, you can supply power to turn on the whole board by connecting your computer, or you can use a simple battery to turn on your Arduino, and the reset button just restarts your whole code. And so here are the power pins that I described, and notice that there's ground pins on both sides, but it doesn't matter which ground pin you use because they have the same purpose. So you're going to have certain inputs and outputs in your circuit, and you would generally plug these into the analog or digital pins. You would choose between these based on your sensors or the outputs you require, and you would also have to factor this into your code. But in general, analog is for continuous signals and digital is for discrete signals. I'll include some resources if you want to learn more about this, but for this video, I'll only focus on digital for simplicity. Okay, another crucial thing to know are breadboards. So you probably couldn't just plug in all your wires into this tiny board, so you'd utilize a breadboard, and it's just a board with some connected holes. So you would connect the power or ground pins or whichever pins you would use to this breadboard, and keep in mind that negative is the ground pins and the positive is the power pins. Also, the color blue generally corresponds to negative and the color red corresponds to positive in circuits. So in this specific layout, you see that the holes in the green part are columns connected vertically, and the rows in the red and blue parts are connected horizontally. So like the whole blue row is connected. So if you connected a wire into one of these holes, you would have current running through it. Now let's talk about how to send instructions to your board to start your project. I'll quickly start off with instructions if you had an actual Arduino board, but I feel like none of us have that as we're stuck in quarantine, but don't worry, I'll show you how to use Arduino virtually. Also, if you're confused on anything, I'll include this doc in the comments along with more resources. So yeah, let's download the Arduino IDE. You can also use a web editor if you don't want to download anything, and you just have to make an account, and the instructions are fairly similar to the ones I'll show you for the program, but you just go here and you go to monitor and put your port and board, and you just run your code. But so yeah, you would download the Arduino IDE based on your OS. I have Windows, so I'm gonna follow those instructions. And when you download the program, my footage actually cut out because there were system prompts and my recording stopped, but just continue with the system prompts that it shows you because you don't have to have any additional settings, and just continue saying yes to everything. And the program, when you download, it should look like this. When you download the program, you should automatically get a file, but be sure to name it and create a separate folder just to be more organized. But your automatic file will generate these methods, void setup and void loop, which are required for any code for Arduino. And to connect your board, your Arduino board, depending on what board you have. You go to Tools, then you go to Board, then you choose Arduino, Genuino Uno, or whatever board you have. Then go to Tools again, go to Serial Port, and it should say the Arduino that you're connected to. And I'll show you like the code that you would use to run on the web editor or like the TinkerCad. And also you have to verify which compiles. Then you upload your code, so it uploads the code on the Arduino to start running the program. Okay, now I'm gonna show you the coolest thing ever, and it's free, so you don't have to buy all the sensors, and you can test out how Arduino actually works. So go to TinkerCad and make an account, and you would have to start a circuit. I'll include the link to it, but you just add project, and it would create a separate like a open Arduino board that you can use. And just say tinker this. Yeah, okay, so this is like the simple Arduino board that it shows up with. So right now I'm going to make a simple circuit and show you what everything does. So they have a lot of modules, right? They have multiple LEDs, but let's just focus on a simple LED circuit, and this is like the code area where you would run the code, and you just click Start Simulation to start your code. Okay, so based on what I told you before about the circuitry, let's make a simple LED circuit. So we can click on any hole and it creates a wire you can essentially place anywhere, but we know that we have to connect the Arduino to the breadboard. So let's put the LED in the circuit area. So we're gonna connect the ground or negative pin to the blue part of the breadboard, and we don't have to connect the positive side of the LED to the 5V. You can just connect it to the digital pins, because they also provide 5V according to the board. And know that the negative side of the LED is the shorter side, and the longer side of the LED is slanted or positive. So let's quickly talk about resistors. So this LED is tiny, right? And it can handle all the voltage that the 5V pin is going to supply. So we're going to connect a resistor to limit the current that's going to go through. So you can place a resistor on either the positive or negative side. It doesn't matter. You just have to connect it. So I'm going to place this resistor, and you can even like control the resistance it provides. But I'm going to place it right. I'm just gonna place it right there. And what I'm gonna do, I'm gonna connect the right side, or like the longer pin, to pin number 10. It does not matter what pin you put, but I'm gonna focus on the digital pin number 10, and we're just gonna have to factor this into our code. And yeah, so like let's go to our code right now. Yeah, you can also change the wires colors. Yeah, so let's go to our code. If you're taking comp sci before, you know that the const in LED1 is a global variable, and you're going to put it outside of your methods, void setup and void loop. You're going to call pin mode, which is a method within Arduino. And since we're using an output pin, right, you would say LED1, which is pin 10, is an output pin. You would have to state that. But then we're going to have a digital write method, which is a really important method. We're going to say that LED1 for that pin is going to set to high. High means that the voltage is set to high, so you're going to provide voltage to that pin. So it's gonna output, and we're gonna delay it 1,000 milliseconds just so we can process that, like our eye can process that. Otherwise it's just gonna suddenly do it. So let's start the simulation. You can see that the light is lit up. So let's alter the simulation and make the light blink. So we're gonna copy the same thing, and we're gonna make it so that LED 1 is gonna be set to low. So it's gonna shine, wait 1,000 milliseconds, then it's gonna stop shining. So it would essentially blink. So you can see like it's blinking right now. Okay, now I already made this for time purposes, but I'll show you how to connect multiple LEDs. So you can see here, it's like the same thing that I showed you before, but you're gonna, on the left side, you're gonna connect resistors to the negative side, and then you're gonna connect wires to the positive side, and you can see you can change the resistor ohms, and then I'm making sure that every single resistor has the same ohms. Then on the right side, right, so you would connect them to different pins, and I would factor this into the code. So like you can see that I connected into pin 3, pin 6, pin 10, and I set that in my code. And now we'll see that, and you have to repeat the same thing that you did for the first one. Now you can see it's gonna blink. So you can see that it's kind of dim. That's because you're powering all of this with one power supply, and we have a parallel circuit, which means that other ones, since they're all running sequentially, they're gonna receive less power. So what we can do, this is also because of the resistance, right? So we can limit the resistance by clicking on the resistors. Now let's do a more complicated circuit, and let's try to use an input and an output. So TinkerCad has a lot of sensors and modules, as you can see here, and I'm going to have a short description of what each module and sensor does in the document that I'm showing here. But for now, let's just use an ultrasonic sensor, and what it essentially does, it just detects an object that's placed in its field of view. So I'm gonna get the ultrasonic sensor from here and place it on the circuit area, and every sensor is going to have different requirements and pins, but this sensor, as you can see here, has 4 pins. So it has the VCC, trig, echo, and ground. So VCC is the positive end, ground is the negative end, trig is the output, and echo is the input. So basically just sends out a sound wave, and then the input pin gets the time taken by the wave to get back to the sensor. Let's start the connection. So you know that the VCC pin is a positive, so you're going to connect it to 5 volts, and this is usually red, so make that red. And ground is going to be connected to ground anywhere, doesn't matter, and you're going to make that black or blue because negative is usually that color. Then we're going to connect the trig and echo pins to the digital pins. It doesn't matter which pins because you can just factor into your code. We saw that earlier. So I'm just going to put this into 11 and 12. Make sure you can differentiate it though, because you don't want to use the wrong pins. It wouldn't work then. So let's go to our code. And for the code, you have to know what your sensor does, right? So like I have the 2 pins, the trig pin and the echo pin. Be as organized as you can be. And you can see that I have variables. Oh yeah, it's 11 and 10. Yeah, see, I messed it up here. But yeah, like this is good now. So let's go to pin. So we know that the trig is output. So we're going to say pin mode, set it to output, and the other echo pin is input. So make sure you differentiate that. And now we're going to use digital write. So you know that so it's going to set both pins and set them to high and then low. So the trig pin will always be on to constantly send waves, and the echo pin will constantly like turn off and on. So let's see what the code does. So when you click the serial monitor, you can see what the code is outputting, and you can see when you click the sensor that you get the field of view. Yeah, so you can see an object, and you can move the object around and see how the values are changing on your bottom right. Your values are changing depending. So if you there's a red part because the sensor can't operate at that field of view. It's way too close for it to operate. Okay, so that's it for my demonstration, and I think the best part about Arduino is that it's cheap, like $30, and especially on TinkerCad, you don't have to buy any of the modules or sensors, and you can play around with anything. Last year we made this haptic vision system with ultrasonic sensors for visual impairment, and I feel like anyone can create cheap and efficient devices, which I think is the main purpose for our org. Okay, so thank you so much for watching. Please be sure to look at the doc I provided.